Let's take a look at some new enhancements that we have inside of Animation Designer in this latest release of NX. The first, and perhaps my personal favorite, is how we can do inverse kinematics of multiple chains. Let's take a quick look at the rigid groups and see what we've got going on. And let's take a look at our joints. We've got a revolute joint on this sort of spinning platter, some revolute joints on this arm, and the chuck or the mount itself. The goal is to have this little blue part rotate in its correct spot, have it rotate about that tower, and have this pad rotate all at the same time. Doing this previously was impossible to do, but now it's quite simple. All we need to do is start up inverse kinematics and change our option from one body to two bodies. Pick our component and specify the orientation. I'm going to have the Z-axis going sort of up into that part, normal to the face. We'll do the same but opposite for the spinning platter. We'll have the Z going up but out of the face. That way both of these vectors actually match up. Once it's done, we hit the play button and it solves just like that. We can use our timeline to see exactly what that contact point looks like. Right on the money. Like I said, doing this manually or before was nearly impossible to do, but now it's quite simple. One thing to keep in mind that inverse kinematics will only solve if there's one solution. Technically there are two solutions here. That platter could be in two different locations, but there's a very limited number of solutions. In this case, inverse kinematics will solve the nearest solution, and that's what it will return. Keep that in mind. If your system has infinite numbers of solutions, inverse kinematics won't work. Let's take a look at another case. This example here involves where you have a couple parts, and the slider has to go back and forth, and this slider has to go back and forth. You can take a look at what we want through color. We want the green part to not only slide across, but actually protrude down while this magenta part does the same thing. As you can imagine, it's going to be pretty simple with inverse kinematics. We'll just simply pick our green part, and we'll take the default going up for the Z direction, and we'll take the default up for the Z direction here. Options that we have is we can specify aligning the axis, the Z, the Y, or the X, or all, but you're going to have a fairly well-behaved case for that to work, or none, which will just get the actual point that you selected earlier. You can specify a tolerance for that point, specify a vector tolerance. You could even avoid collisions or generate a tracer all at the same time. So just like that, before my finger was actually off the mouse, it does its magic. So notice how both parts slide over, and the green part not only slides, but it has got to come down to meet the face of that magenta colored part. Pretty fancy. Last case here is a slightly more complicated case, and if you take a look at the side view, the parts don't actually line up, and the rotation is going to have to get adjusted as well. One of my favorite things to do when evaluating a case to see if inverse kinematics will even solve is go to the joint jogger command and dance through some of the ranges of motion. We know it works that way. We know this will slide back and forth, and we know this arm has got to rotate around, and we know that head's got to pivot sort of back and forth, but what we don't know is exactly how far that pivot motion has to go. So we'll let inverse kinematics do all of this magic for us. We'll simply pick our part first, and I'm going to pick this center point, and again the Z-axis will have this going inside of the part, actually out. It doesn't really matter, just as long as both vectors are aligned and in the same direction. And we'll simply double click that arrowhead to get the Z in the opposite direction, hit the solve button, and there we go. Hit the play button, and it does all of its solving magic for us. Not only does the part rotate properly, but notice how it has to slide across to meet the conditions there. If you change my color on, you can see exactly what the green part is having to do, how it rotates and slides out. We did that with a cylindrical joint. Keep that in mind that you may have to use different joints than you're used to in the past to allow things to solve. Inverse kinematics, whether you're using one body or two body, doesn't work on every single joints. You'll find them working on revolved, slider, and cylindrical joints. All right, let's look at something new. In the past, we did have flexible cables, but it was a feature toggle because it wasn't production ready. Now I'm excited to announce that it is. If we hit the play button, we can see exactly what's happening here. We have our printer head going up and down, sliding back and forth, but we have this cable dangling off in space. The previous ants that we got in our pre-production build that gave you a very odd answer that was difficult to control. Here, I'll show you how easy it is. Let's stop our animation, and using our flexible cable command, we can animate a curve, a body, or a parameter. I'll simply pick this body, and I'm going to add a couple of attachment points. The first attachment point will be on this very large printer casing, and the component that it's going to connect to is just this sort of round area here. Then we'll add one more attachment point on the opposite side of the model, and we will pick this stepper motor, and somewhere near that point of contact on that stepper motor. Then we hit the OK button. It creates the joint appropriately, or I should say the flexible cable appropriately. Then we hit play. You can see how this thing is going to bounce up and down in a very, very well-behaved manner. Keep in mind, flexible cables are only ideal or only can be used for circular cross sections. Ribbon cables are out and bundles of cables are out. Really only wires and lines that could be used in a hydraulic type application. This demonstration showed a flexible cable tied at both ends. You could have intermediate tie-down points for like cable ties if you wanted to do that. Simply add those poses to your definition step. All right, next on the list here is a new point on curve kinematics chain. If you tried to animate this in the past, you had a ton of joints and a ton of work that you had to do. Now it's a snap. So what we've done is we've already created a link, and I'll show you some rigid groups here. Now, don't be alarmed by all the rigid groups. This was created by one rectangle select, and we got everything. Quite simple to create. We have one point on curve for one link, or one part of our link, one point on curve for the other part of our link. That way, there's a sketch along here that's going to ride along the actual curve that defines the shape of that chain. The point on curve kinematics chain simply indicates what has to follow that master link. Then you apply a speed motor to it, and just like that, you can play this inverse kinematic, or this chain. Pretty interesting. Imagine what your machines will look like when you show your customers how real things really are. Nice enhancement in Animation Designer. All right, last on the list are a few nice capabilities. Taking a look at this machine, let's go ahead and hit the play button, and you can see exactly what's happening. I already have the rigid groups defined. I've already got the motion defined using inverse kinematics to get the picker upper arm, the gripper, to go down and pick something on that rotating cylinder in the very center of our model. A couple things we've added to make things a little bit easier on your eyes and a little bit easier to work with is the ability to show and hide rigid groups. Maybe you're defining something in a very, very complex machine, and you want to start hiding things so you can better focus in on exactly what you need to work on. That's what this show and hide capability will allow you to do. And the other one of my favorites with this particular model here, is a new time scale. Let's go ahead and start our model. And if you want to dial in on something and see exactly what's happening in slow motion, you can activate this time scale and crank the scale way down and slow things way down, and you can dial in on exactly what is happening in your model. And notice how the disk is rotating very slowly, and the transport mechanism is moving very, very slowly as well. If you want to speed things up, dynamically move this back and forth, and you can control the exact playback speed of your animation. So if you want to see it real fast to get to the end point real quick, you can do that. If you want to slow it down to focus in on an error or an area that might be a potential area to add some more design work to, you can do just that with this time scale operation. All right, well, that covers some of the new capabilities. I hope you enjoy this new version of NX. Thanks for watching.